Hello and welcome to all. Today we will discuss about the new chapter which is refraction of light. First of all, we have to understand the what is refraction. Refraction is basically a phenomena in which the path of light rays changes its direction when it is passes from one transparent medium to another transparent medium. This phenomena is known as refraction. As we know that the motion of light rays is always in a straight line. But if the medium of travel of light changes, the direction of light is also affected by the medium. It changes its direction to its normal position, which is known as refraction. And refraction is a surface phenomenon. Here is the diagram related to the refraction. This is the partition line or boundary between two medium 1 and medium 2, and on this horizontal boundary line a normal is drawn. This is the normal line. This dashed line is normal line. This is the normal line which is always perpendicular to the this separating line, and this is the incident ray. That direction of ray is shown here. This is the incident ray and this is the refracted ray. And if reflection takes place, then this will be the reflected ray. We have to consider these two ray, incident ray and refracted ray. Here angle of incidence is the angle of incident ray with normal line is known as angle of incident, which is represented here. The small angle I is the angle of incidence, and the refracted angle is the angle between refracted ray and normal is known as angle of refraction, and it is represented by small r. Here angle r is angle of refraction. Then there is a tendency to dif- to deviate the line of normal. The actual path of the light rays is from the incident ray directed in a straight line. This is the actual path of the light ray. But if the light rays travel from one medium to another medium, the direction of path of light is deviated from its normal path. It may be towards the normal or away from the normal. This is the two possibility of changing the path of the light when passes from one medium to another medium. The first condition is if a ray of light travel from rarer medium to denser medium. Rarer medium to denser medium means the density of the particle of the medium is less than the medium is known as rarer medium, and if the particle of the medium is much more, then the medium is known as denser medium. Then it is said that if a ray of light travel from rarer medium to denser medium, the light ray bend towards normal. This is the normal. Light ray bend towards normal. Here, this is the diagram for this condition. Medium 1 is rarer medium and medium 2 is denser medium. Medium 1 is assumed as this is the medium of air. Here air is present and medium 2 is glass or maybe water. Both are denser as compared to air. This is medium 1 is air and medium 2 is glass. In this condition, the incident rays after refraction, it bends towards the normal. That is, there is a deviation in angle of the refracted rays. This deviation angle is represented as delta. In this case, if light rays passes from rarer medium to denser medium, the I angle I will be greater than angle R, because the light ray bends towards the normal. Therefore I will be greater than the R. That is, angle of incident is more than the angle of refraction, and the deviation can be obtained as deviation. Here deviation will be equal to, here deviation is represented as delta. Delta will be equal to angle I minus angle R. This is the deviation when light rays passes from rarer medium to denser medium. Second case is when light rays travel from denser medium to rarer medium. This is the denser medium. We can assume that it may be water or glass, and this is the below one is the rarer medium. This is the rarer, and it is assumed that this is air. Then if a ray of light travel from a rarer medium to denser medium, the ray of light is bent away from the normal. This is the actual path of the light ray, and here this is the refracted ray which is away from the normal. In this condition, the angle of incidence is lesser than angle of refraction. Here R is the angle of refraction, it is the angle of refracted rays from the normal, and this is the incident angle. Here R is greater than I, and this is the deviation. Deviation is basically the angle of a refracted ray from the actual path of the light. Then the deviation is represented here delta. Delta is the basically deviation. Deviation will be equal to the refracted rays minus incidence ray, that is R minus I. Here is the another condition related to the refraction. If incident ray coincides with normal, that is, if incident ray is travel along the normal, then there is no deviation takes place. This is the incident ray and this is the normal. Incident ray passes along the normal, that is the incidence angle is 0, and here we can see that there is no deviation in the path of the light takes place. Then if incident angle is I equal to 0, then the refracted angle is also equal to 0. There is no deviation takes place. This is the third condition or third possibility for the light rays travel from one medium to another medium. This is the medium 1 and this is the medium 2. It may be rarer, or it may be denser, or it may be denser, then it may be rarer. These are the three possibilities related to refraction of light. Now here we have to discuss about the law of refraction. The first law of refraction states that the incident ray, the refracted ray, and normal to the interface of two transparent media at the point of incidence all lie in the same plane. This is the diagram. This is the incident ray. This is the normal, and this horizontal line is the interface between medium 1 and medium 2, and normal is the a line which is drawn perpendicular to the interface, and this is the incident ray, this is the reflected ray. This law states that the incident ray, a refracted ray, this is the refracted ray, and normal to the interface of two transparent media, this is the normal to the interface of two transparent media at the point of incidence, this is the point of incidence, this point is the point of incidence, all lie in the same plane. These three lines, incident ray, refracted ray, and the normal, all three lines lies in the same plane. This is the statement of first law of refraction. And the second law of refraction. Second law of refraction, it states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media and for a given wavelength of light. This second law of refraction is also known as Snell's law. This is also known as Snell's law. It is very important questions. The statement of second law of refraction can be written mathematically as it is the ratio of sine of angle of incidence. Sine of angle of incidence is sine I, and sine of angle of refraction is sine R. Sine I upon sine R will always be a constant. This is represented as mu12. This constant is known as refractive index. It is fixed for given pair of media like air and water, air and glass, water and glass, like that. In previous lectures we have discussed about work power energy. If you have any doubts related to any concept of the previous lectures or any questions, then you can mail me at amarendra038 at the rate gmail.com. You must revise the previous lecture, and on the basis of lecture it is very necessary to solve some questions related to those concepts. Thank you.